Hello. In this video we're gonna examine a few questions and problems regarding the objective 2.2 of the 11SP Physics Mechanics course. Now the statement of the objective is to describe the forces using a free body diagram. If you want, you can pause the video in order to read the full description of the objective. However, the major key points is that we use representations of forces with arrows that act on the object. So this kind of drawing, this kind of diagrams, we call them free body diagrams, and they show the forces that act on the object. Now, the forces we can draw them as they act on the object, with an arrow that starts from the center of mass of the object to the direction where the force is applied. For example, the force of gravity, we know that it is always applied straight down. Now, the length of the arrow shows the magnitude of the force. For example, from this free body diagram, we understand that there is a strong force of gravity downwards and a smaller force of resistance upwards. And again, in a similar way, we draw the forces as they act on the object. Now, a little bit careful, we only draw the forces acting on the object. If we need to demonstrate velocity or acceleration, then we draw them with arrows a little bit further away from the object, somewhere on the side of the object. So from the center of mass of the object to the direction that the force is applied, we draw the free body diagram. Now we can answer a few related questions. The first related question is about a person in an amusement ride in the rotating cylinder, and we need to draw the free body diagram. We need to select the correct free body diagram of the person as he is rotating with a great speed on this cylinder. Now, the question mentions a few details. For example, that when the cylinder is rotating with a great velocity, suddenly the floor drops and the riders are suspended. This means that the riders stay there. That's because of the great speed that the cylinder has. And now I don't know which is the correct answer, but I know that for sure the force of gravity will be acting downwards. And since the surface of the cylinder, the wall of the cylinder the person has the back against the wall of the cylinder. Now the wall applies a force towards the center of the cylinder. This is a centripetal force, but this is also the force from the wall, so it is a normal force. And since the person is suspended, it means that he doesn't fall down. There must be an opposing force to the force of gravity. This force is the force of friction. So the best free body diagram acting on the person, that shows the forces that act on the person, is diagram E. We can continue with another question where the question mentions that something is moving in a surface without friction, initially with a velocity of 200 meters per second to the left. So we have an object, a block, moving to the left with a speed of 20 meters per second. There is a horizontal force exerted to the right of the object for a small time, and the magnitude of the force is given from the equation F is equal A times T. Again, there is a force that is applied to the person. And the question is, which of the following free body diagrams shows the forces acting at a certain time? So there will be a force to the right. However, these are not the only forces that are acting. For sure, there is force of gravity and the force from the floor. Since there is a horizontal surface, there will be a force from the floor. This is a normal force. And now there is no other applied force. There is no friction, so the best diagram is E. We can continue. We have an object that it is suspended from a string, and the string is attached to a box at an inclined surface. And again, there is negligible friction between the box and the surface, so there will be no friction. And again, we need to see what is the free body diagram. on planet Earth, there is the force of gravity straight down. There is the force from the surface, the normal force that acts on 90 degrees with the surface, so there will be the normal force somehow like this. And since there is a string, there must also be a force from the string. We call this tension. And if we'll have a look at our diagrams, the only diagram that makes sense is diagram C. Now, diagram A is wrong because the force of gravity is not acting sideways on the inclined plane. In a similar way, the tension is the direction on the direction of the rope. The tension should be on the direction of the rope, and the tension should be on the direction of the rope, so every other diagram is not correct. We can answer one more question. Now, a box is sliding up on an inclined plane, and we need to figure out what is the free body diagram on the object in position 1 and position 2, knowing that the friction and the air resistance are negligible. Now, for location 2, the only force that is acting on the box as it is flying, as it has left the inclined plane, is the force of gravity. So on location 2, the only force is the force of gravity. No, there is no normal force, there is no force of air resistance, there is no friction. The only force is the force of gravity. So for sure, the correct diagram, the correct free body diagram is B. However, the reason why B is correct is because if we are at location 1, there will be the force of gravity straight down and the normal force forming 90 degrees with the inclined plane. Now, a little bit careful, there is no applied force, so there is no force to the right on the inclined plane, and there is no friction, so there is no force downwards the inclined plane. Now, again, this object probably was given a push at the beginning, so maybe at the very, very, very start there was a strong force that made the object move, but as it is moving, and since no one is pushing it, there is no applied force to the direction of the inclined plane. So there is this free body diagram, A and C, are definitely not correct. And actually A is not correct because the direction of the normal force is not straight up, but it is sideways, forming 90 degrees with the inclined plane. And also in location 2, the only force of gravity is the only force is the force of gravity, so diagram D, the combination D, is definitely wrong. Feel free to email me if you have any inquiries or comment, and have a good day.